Hello everyone, I'm Tarun Kaushik, and today in this lecture we will be solving some questions of analytical geometry, and we will be solving those questions of UPSC, the topic which we have discussed or learned in our past 6 chapters, or you can say past 6 videos of this analytical geometry. Now let us start. So the first question, this question I have already discussed in my first lecture of analytical geometry, that to find out the locus of the point of intersection of the three mutually perpendicular tangent planes to the conicoid ax square plus by square plus cg square. This was asked in 2016, 15 marks. Okay, so this question I'm again repeating so that you will not have to, you can say that those who are you can say that watching this video for the first time, they will know that how to solve this question. Okay, this conicoid, the conicoid which is given is this. Okay, now let us suppose it is saying that there are three mutually perpendicular tangent planes. So we are taking that the one of the mutually perpendicular tangent plane to this equation number 1 is given by this equation, that is L1x plus M1y plus N1g equals to P. Okay, so according to the condition of tangency is that the square of the L1 square plus divided by A and M1 square divided by B plus N1 square divided by C equals to P square. So from this equation we can calculate the value of P, and that comes out to be this. Okay, now we have to substitute this value back into the equation of the L1, or can say that the condition of tangency. After that this equation, or can say that the second equation, which first equation of mutually tangent plane, that becomes this. So similarly these three equations become the same in this form. Okay, now if we add these three equations, okay, now this equation become this. Now we know that this L1 square plus L1 square plus L2 square plus L3 square, this comes out to be 1, this comes out to be 1, this comes out to be 1, because the sum of the direction cosines results into 1. I already discussed. For much more details you can go and watch the first video of this series. Okay, after that you just what is the basic idea, just calculate the tangent equations plane and put them, or you can say that add these three different equation and put them equal. So after that you get this x square plus y square plus z square equals to 1 by a plus 1 by b plus 1 by c only. Okay, now the next question in the 2016 only. Okay, and the question for the 10 marks in the compulsory question, we have to find out the equation of the sphere which passes through the circle x square plus y square equals to 4 and g equals to 0, and it is cut by the plane. This plane is given in a circle of radius 3. So the radius is given, the plane is given, and this sphere circle is given. Okay, and this g equals to 0, it is also given. Now we know that x plus y square equals to 4, this is given, and g is also equals to 0. So I can write it, since this g is 0, so I can add 0, subtract 0, there will be no problem in addition. Okay, 0 creates problem whenever we divide or multiply. Okay, so in addition there will be no problem. So I can write it x square plus y square plus z square minus 4 equals to 0. Okay, so this required spheric equation is the intersection of the above two, isn't it? The sphere which is given, this sphere and this plane is given, so the required equation will be the intersection of these two. So the intersection is given by this equation. Now the center of this sphere is given by this equation, by just subtracting, or you can say that identifying the value of u, v and w, which we have, you can say that, calculated in our last lectures. Okay, so the center we have calculated and the radius we have calculated, and the radius, how much it is given as, this is 3. So just substitute this value as 3. Okay, and calculate the value of k. When you calculate the value of k, so this value of r, you can say that is this value is already given as 3, already mentioned. This radius is 3, isn't it? No, so sorry, I'm very sorry. This is not 3. What is 3? The 3 is the circle radius, it is not the spheric you can say that radius. This radius is, we have to calculate by the formula from this center. We know the point coordinate of center, we know that then the radius will be given by this formula. Now this you can say that this direction, or you can say this line is tangent to this plane. So if we can calculate the tangent, or you can say that the line, or you can say that the length of the perpendicular drawn from the center to this plane, how we can calculate? So just substitute the value of this point into the equation of the plane. And what is the equation of the plane? Which is already given, and the equation of the plane is, this is the equation of the plane. This is x plus 2y plus 2g equals to 0. This is the given plane. So we have to find out the, you can say, the length of the tangent, or you can say perpendicular, drawn from the center to this plane, and it can be calculated. Just substitute the value of x as 0, y as 0, and z is equals to minus k by 2. Okay, and do the square, and just you can say that put this value and get this answer. So you get this p, the distance is comes out to be k by 3. The perpendicular distance you have already calculated, that comes out to be k by 3. Now this k by 3 value, this distance, yeah, this distance is k by 3. This distance we have calculated, this is this k square by 4 plus 4 and under root, and this is 3. So I can, you can say that sorry, this is the my hypotenuse, this is my perpendicular, and this is my base. So this 3 square plus p square equals to this square. So using the Pythagoras theorem, just use this perpendicular square equals plus base square equals to hypotenuse square. Just use this property and solve this quadratic equation. From there you get the value of k, that comes out to be plus minus 6, and put the value of k back into the equation. You get this our required answer. Okay. Now in the last lecture I mentioned that I will explain the benefit of solving those exercises which I used to you can say that focus, or you can say that I told you to focus on that exercises, because this question was taken from that exercise only by the UPSC. Okay, and you can see that the exercise number 6.6 I already uploaded in the, you can say that, part analytical geometry part 5 lecture. You have to download, or you have to see. Okay, exercise number 6.5, and the question number 6, I think, or 4 questions, question number 6 or 4, I don't exactly remember. Now next question, we have to find out the shortest distance between the line, this line and this line is given. So we have to, and for what value of m these two lines will be intersecting. Okay, the first line is given, and now we have to write this equation in this in such type of Cartesian form. How to write? This is y equals to, this is, you can say y minus mx is 0, this is 0, and z is equals to 0, this g equals to 0, and y minus mx is 0. So this means y equals to mx and g equals to 0. So I can put this m into the denominator side. So it become x by 1 equals to y by m equals to g by 0. So this is my second line, and this is my first line. So in the very first lecture I told you how to calculate the two you can say the distance between the two skew lines. Okay, now this point, you can say that this is 1, 2 and 3, and the point of this is 0, 0 and 0. Okay, this is a1 and a2. Just write down the points, and here write down the directions. So the direction of the first, that is b1 2 4 1, that is 2 4 1, and the direction of the second is 1 m 0, 1 m and 0. So just calculate the cross product of these two, and after doing that you get your cross product comes out to be this, and take the magnitude of that, just take this magnitude. Okay, and subtract these 2 points, get this answer. Now you have to do the dot product of these two. Okay, just do the dot product of the a2 minus a1 and b1 cross b2. Just do the cross product, then you get this portion, and the magnitude is comes out to be this. So this is the this is 0. This, when you solve it, it becomes minus 5m plus 10 divided by 5m square minus 16m plus 16 under the root, and this is our shortest distance. So we have to find out the value of m so that these will intersect. So for intersecting, so the distance will become 0. So put the distance, for example, this is the intersecting point, and at this point the distance between these two lines becomes 0. So just substitute the distance is equals to 0 in this is the formula of distance. So when this portion, this will get cancelled, and we are left with minus 5m plus 10, and from there m comes out to be 2. Okay, so this was the question. Now the next question that was asked in 2015, for what value of what positive value of a this plane. So we have to find out the value of a, and which value, the positive value of a, this touches this plane touches the sphere, this touches this sphere, and find out the point of contact. Okay, now what we have given this spheric equation. Okay, and the center of the sphere we can calculate by identifying the coefficient of x, y and g. Okay, the center we know, radius we can calculate. So what will be the radius? Radius is nothing, it is just the perpendicular distance from this point C to this plane. How to calculate? We just understand in our last lectures also, or in this lecture also we have studied. So just calculate the value of r. Okay, and this will become the r is nothing, this is 3, this r is equals to 3, then this will be the perpendicular distance from this point to this point. Okay, so just substitute this value in the plane and divided by the square root magnitude of the coefficient of x and y and g, and add these two. And since r equals to 3, so just substitute this. I am squaring both sides, so 3 becomes 9, and this becomes, so after solving this becomes a plus 7, and do the square, so it becomes a plus 7 whole square divided by this square under root get cancelled, and it comes out to be a square plus 5. Just do the cross multiplication, solve this quadratic equation, then there you get the value of a. That the value of a comes out to be two values, that is 2 and minus 1 by 4. So we have not to take the negative value as it is mentioned in the equation itself, so a comes out to be 2. So just put the value of a, that this becomes a complete plane equation. Now the center we are having, this is the center, and the coordinate of center is 1 2 and 1 2 and minus 1. This is a straight line. Okay, and this is the plane. Okay, this is the plane equation, this is the equation of a plane, and this equation of a plane will, and then this line will be, you can say, then in the same proportion. Okay, so these are the direction cosines of this, and put them equals to r. Calculate a generalized point, put the generalized point back into the equation, from there find out the value of r. Now put the value of r again in this portion, get the value of the point. So the point comes out to be minus 1 4 and negative 2. So it will be the point of contact. Next, we have to obtain the equation of a plane passing through the points this and parallel to x-axis, so that this plane is given, and the equation of a plane is given by this equation. For example, you can say that now this a we have calculated, or you can say that we have solved this question, and we were here. Okay, now the question was, obtain the equation of the plane passing through this point and parallel to x-axis. So this is the equation of a plane which is given by a into x minus x1 plus b into y minus y1 plus c into g minus g1, where this a, b, c are the direction cosine of this given plane. Okay, these are direction cosine, or direction ratios. Now these 2 points are lying on the plane, so you can say that substitute one of the x1. I am assuming that I am taking this point, so it becomes x minus 2, y minus 3 and g minus 3, and the direction cosines I am taking it direction ratios a, b, c, so it equals to 0. Now this point b, this is the required equation of our plane, but this point b, this is also lying on the same plane. So if we substitute this value in this plane, so it will definitely satisfy the equation. So just substitute these values and get one value of a. You can see the equation that comes out to be in the form of a, b, c. Okay, now the direction cosine of a line parallel to x-axis, it is given by 1 0 0. It is parallel to x-axis. Okay, so it will be given by 1 0 0. Now the direction cosine of a line and of the plane will be perpendicular. How? Because this is a, you can say that plane, this is the direction cosine, and a line is this, so these two are perpendicular, so the direction cosine will be perpendicular to each other. So what is the perpendicular of a line? So that because it is saying that this plane is parallel to the x-axis, and x-axis having the direction cosine 1 0 0, and the direction cosine of this will be in this direction, so both will be perpendicular. So and the direction cosine of this is ABC, and their direction cosine is A00. So B get cancelled, C get cancelled. So A into 1 comes out to be 0. So A equals to 0 will be the direction cosine of this. Okay, so A comes out to be 0. Since A is 0, so just substitute this value back into the first equation. That is, this A is 0. So we are left with minus 8C plus 2C equals to 0. Then C comes out to be 4B. Now the value of A 0, C is 4B, and B is already B. Now when we substitute this value back into our main, you can say that equation of the plane, so it comes out to be this b I kept it as it is, this 0 get cancelled, this c will becomes 4, this is not cancelled, this is 4b, I am replacing this c by 4b, so it becomes 4b, this is b, y into this, and 4b, so this b get, if I take this common and divided by both side by b, so this b get cancelled, so I left with only this portion. So it becomes y plus 4g minus 7 equals to 0. So this is the required plane. Okay, so that's all for this lecture. And if you really like this video, please click on the like button, and please do not forget to subscribe to my channel for getting the latest update directly into your email account. And at last, I will be, you can say that I will be coming with much more questions of UPSC of this analytical geometry after we will completing the next portion, left portion of this analytical geometry, such as planes. Okay, and you can see that much more still remaining. So after doing all these, I will be doing much more questions. Okay, so that's all for this lecture, and thank you very much for watching this video.